Look at the satellite feed. A massive atmospheric engine has just ignited in the Pacific, and its trajectory is alarming. This is Typhoon Macala, designated as Storm 07W, and it is currently rewriting the forecast for the entire Philippine Sea. We are monitoring a situation that transitioned from a standard system into a monster in hours. The latest reports from the Joint Typhoon Warning Center indicate that Macala has officially entered a phase of rapid intensification. This means the sustained winds have surged by over 30 knots in a single day, fueled by some of the warmest waters on the planet. Right now, Macala is screaming across the open ocean with sustained winds of 175 kilometers per hour. Gusts are clocked at over 215 kilometers per hour, and central pressure is plummeting. When the pressure drops that fast, it tells the storm's core is tightening into a lethal, high-velocity vortex. This isn't just a storm. It's a thermodynamic heat engine operating at peak efficiency. The Pacific warm pool is acting like a massive reservoir of high-octane fuel for this system. Ocean temperatures in the direct path of the storm are sitting between 29 and 31 degrees Celsius. But the real danger lies beneath the surface in what scientists call the ocean heat content. Most typhoons eventually slow down because they churn up colder water from the deep ocean as they move. Macala doesn't have that problem because the layer of hot water in this region is incredibly thick and deep. There is no natural braking mechanism to stop this intensification process. We are looking at a forecast that takes this storm all the way to 241 kilometers per hour. That is the official threshold for a super typhoon, the highest and most dangerous classification a storm can achieve. The path is currently locked onto the Ryukyu Islands, a chain that sits on the front lines of this escalating crisis. Over 1 million people live in the impact zone, including the population center of Okinawa. Strategic assets, including Kadena Air Base, are now officially within the cone of uncertainty as the system begins its turn. A high-pressure dome, known as the subtropical ridge, is currently guiding the storm's movement like an invisible hand. As that ridge starts to weaken, Macala is expected to undergo a process called recurvature. It is essentially hooking its path directly toward the north and northeast, aiming straight for the southern heart of Japan. This is a critical moment for anyone in the Sakushima Islands, including Miyako and Ishigaki. These low-lying islands have very little defense against the wall of water. This storm is likely to push ahead of it. We are watching a collision between extreme atmospheric energy and one of the most vulnerable coastlines in the world. Every data point we receive at Terra Alert suggests this event is only going to get more intense as the weekend approaches. But while the wind speeds are the headline, there is a technical battle happening behind the scenes that you need to understand. Depending on which government agency you listen to, the severity of this storm might look completely different. As there is a gap in how nations measure wind speed, causing confusion on the ground. One agency might call this a catastrophe, while another labels it less severe. This discrepancy isn't a mistake. It's a difference in scientific dialect that could leave you unprepared if you don't know the facts. As we dig deeper into the data, we are also seeing signs of an eyewall replacement cycle beginning to take shape. This could temporarily drop the top wind speeds, but it might actually make the storm much larger and more destructive. We are tracking every shift in the wind field because the true scale of Macala is finally starting to reveal itself fully. If you are looking at the live data, you might see two different numbers that seem to contradict each other. The Joint Typhoon Warning Center reports 175 kilometers per hour, while local Japanese sensors show significantly lower. This is not a mistake. It is a critical scientific distinction we call the category gap. JTWC uses a 1-minute average, capturing the most violent high-intensity gusts. In contrast, the JMA uses a 10-minute average, which provides a more sustained look at the storm. If you only follow one metric, you are missing half the story of how Macala is truly behaving. Both measurements are correct, but they describe different types of destruction now barreling toward the Ryukyu Islands. This discrepancy often causes people to lower their guard, assuming the storm is weakening when the opposite is true. Looking at the satellite loop, we can see the eyewall replacement cycle is now in its most volatile phase. The inner core is fragmenting as a secondary, much larger outer eyewall starts to choke the primary vortex. Do not be deceived by a temporary dip in peak wind speeds during this complex transition. This is the typhoon reloading, expanding its reach to cover a much larger geographic area. Think of a figure skater extending their arms. The rotation slows, but the footprint becomes far more dangerous. As that outer ring hardens, the wind field expands, meaning the danger zone for the Ryukyu chain is wider. This terrifying expansion is fueled by an incredible amount of ocean heat content sitting just beneath the Pacific surface. We aren't just dealing with warm surface water. The Pacific warm pool here is deep. Ordinarily, a typhoon churns up cold water from the depths, which acts as a natural brake on its intensity. But Macala is moving over a fuel tank so deep that the storm cannot find cold water to slow down. Temperatures between 29 and 31 degrees Celsius are providing high-octane energy for this runaway thermodynamic engine. This heat explains the rapid intensification we witnessed earlier, where the storm surged 30 knots. Every indicator confirms Macala is still on a trajectory to hit Super Typhoon status before reaching the Japanese archipelago. The JTWC is forecasting a peak of 130 knots, or roughly 241 kilometers per hour, by the weekend. That puts Macala at the top of the scale, posing a critical threat to the front right quadrant. In the northern hemisphere, this kill zone combines the storm's internal rotation with its forward movement for maximum impact, as, if your location falls within this sector, physical forces hitting your home are nearly doubled. We are also tracking the central pressure, which has dropped to 935 hectopascals and is plummeting. This low pressure acts like a vacuum, physically lifting the ocean and creating a lethal storm surge foundations cannot withstand. Surge is the primary killer in these events, especially for low-lying areas like the Sakushima Islands. As the subtropical ridge to the northeast buckles, Macala is being forced into a dangerous northern recurvature. This hook path brings the eye toward populated centers like Okinawa and Kadena Air Base. These communities are facing a triple threat of extreme wind, rising sea levels, and rain-induced landslides. But there is a hidden variable in this disaster that most experts are completely ignoring right now. The path of this typhoon takes it directly over one of the most unstable geological features on Earth. We are talking about the Ryukyu Trench, a massive subduction zone at a critical plate boundary. This trench is a tectonic powder keg that hasn't seen a major release of energy in over 2 centuries. Atmospheric pressure and water weight are moving toward a region with a dark history of massive tsunamis. This underwater canyon is where the Philippine Sea Plate dives beneath the Eurasian Plate. Recent GPS data from 2021 indicates these plates are simply no longer sliding smoothly. Instead, scientists have identified locked patches along the subduction zone. These slip deficits suggest the fault is storing a terrifying amount of tectonic strain. While a typhoon cannot trigger a mega-thrust earthquake, the atmospheric pressure changes are moving over a region with a dark history. In 1771, a magnitude 8.0 event devastated this area. That disaster, known as the Meiwa tsunami, produced a wall of water that slammed into the Sakushima Islands. 12,000 people lost their lives in a demographic catastrophe. Today, over 1 million people live on these islands, concentrated primarily on Okinawa. This includes strategic military assets like Kadena Air Base, now squarely in the path of Macala. As the storm approaches, we are tracking a triple threat sequence. The first stage is the physical impact caused by Macala's sustained winds, currently clocked at 175 kilometers per hour. These gusts, reaching over 215 kilometers per hour, will shred the power grid and turn debris into lethal projectiles. But the wind is only the opening act. The second and most dangerous threat is the storm surge. Low atmospheric pressure and extreme winds are pushing a massive wall of ocean water directly toward these vulnerable coastlines. Low-lying islands like Miyako and Ishigaki have almost no natural defense. Safety depends entirely on reaching higher ground or reinforced concrete structures before the water arrives. The third stage is the moisture shield. Macala is acting as a massive heat engine, drawing energy from a Pacific warm pool that extends deep below the surface. This deep layer warmth prevents the storm from churning up cold water, allowing the engine to run at maximum capacity. This thermal energy is what fuels the storm's intensification. Even before the eye makes landfall, outer bands are interacting with stationary fronts. This is already triggering dangerous landslides across Kyushu and western Japan as the moisture shield arrives. We are also monitoring for eyewall replacement cycles. If the peak winds drop, do not be fooled. An eyewall replacement often results in a significantly wider and more dangerous wind field. Regarding intensity ratings, the Joint Typhoon Warning Center uses a 1-minute average. This results in higher headline numbers than the 10-minute average used by the Japan Meteorological Agency. Neither is wrong. They are simply different scientific dialects. However, the physical threat remains the same regardless of the measurement scale used to describe the storm's top speed. The front right quadrant of Macala is the most lethal sector. The combination of the storm's rotation and forward motion creates an additive effect of pure atmospheric violence for the islands. For those in the path, the next 72 hours are critical. Island geography means there is no driving inland. Vertical evacuation is the only viable strategy left for survival. The data shows this system is not backing down as environmental conditions remain optimal. The intersection of atmospheric power and geological instability is reaching a dangerous breaking point. Stay tuned to Terra Alerts for real-time updates as this emergency evolves. Your safety depends on staying informed with the latest data and ignoring the misinformation currently spreading online. This is a developing situation that demands your full attention. Make sure to subscribe and hit the notification bell so you do not miss our critical and urgent emergency updates. Leave a comment below with your local weather conditions. We are watching the feeds and will bring you the facts today. Thank you for trusting Terra Alerts for your disaster monitoring. Stay safe, stay prepared, and follow all local evacuation orders without delay. We will see you in the next emergency report as Super Typhoon Macala moves closer to impact this weekend.